In this problem, we would like to find this longest sublist with the numbers of zeros. So let's see the different solutions. The first one is very direct idea. Let's generate all of the different windows. Remember, when you have to try everything in algorithms, we call that as a brute force, which means you don't think about it. You just do all of the best possible computations. To try all of the different windows, we have an index ranging over the list, index 2 starting from index +1. This means we are trying every sub window. And for every sub window, we will get the sublist, then count the number of zeros, get the number of ones. Are they equal? Yes. Maximize or check the longest one among all of them. That's all. Easy to write, easy to code, easy to think about it. Let's try to make that a bit more efficient. The moral of the idea is as following, and we have something that's close to that before. Instead of like duplicating a lot of your efforts, you can, when you start from an index 1, you keep growing step by step, and you just keep accumulating the number of zeros and ones that you have so far. For example, let's say that you started from this index. Now we have a single one. Now 1 1 and 1 0. Now 1 1 and 2 zeros. 1 1 and 3 zeros. 2 ones and 3 zeros. 3 ones and 3 zeros. This is an equal position now, and so on. Now again, starting from the second position, 1 0, 2 0, 3 0, 1 1, 3 0, 2 ones, 3 zeros, 3 ones, 3 zeros, a match, and so on. So the idea is, you start from an index, keep expanding your window as much as you can for the end, and just keep accumulating how many zeros and ones you have. As you see, the code is still simple, easy to read, and this time you are just trying every couple of windows, but actually this loop is trying them in a smart way. This is a medium level solution. I'm going to explain a solution that is a bit hard, okay? So if you didn't get it, this is totally okay. I know that the solution is a bit hard. The observation is as following. Let's say we have the following array here, and this is the indices corresponding to it. In position 0, how many ones and zeros we have? In position 0, we have 1 1 and 0 0. In position 4, how many ones we have? We have 3 ones. How many 2s we have? We have 2 zeros. Let's cancel the number of ones and number of zeros that are equal. So if we are going to do that, we can get the following. 2 ones can cancel 2 zeros, right? So the remaining for you is 1 and 0 again. The moral of that is, you can also think of it as like the difference between number of ones and number of zeros. So here we have 1 1 and 0 0, so we have 1 minus 0 is 1. 3 minus 2 is 1. So think of it like the difference between number of ones and number of zeros. Or just cancel the number of, like, take the minimum and like subtract it, but get the total number of 1 0. So every equal number of 1 and 0 it can be cancelled together. For example, if you have let's say that you have 4 ones and 6 zeros, this is the same as 0 and 2. If you have 8 ones and 10 zeros, this is same as 0 and 2. If you have 8 ones, 11 zeros, this is same as 0 and 3. You just get the minimum and subtract it from the two guys to get something that equivalent for us here in terms of the difference. Now the question here, what does it mean to have two positions with the same value of total ones minus total zeros? Like in our case here, 1 minus 0 is 1, 3 minus 2 is 1. What does it mean to have two positions that have the same difference between number of ones and number of zeros? It means that the in between of these two positions must have number of ones equal to number of zeros. Specifically here, we have this 0 and 4. Specifically from 1 to 4 must have the same number of zeros. The logic here is, if this position have the same as mine, then the early part can be cancelled with my part. Maybe I can explain it here with some example. Let's say that we have here 0 1 2 3 4 5 6 7 8 9 and 10. And let's say we are at position X, and the number of ones and zeros, like the number of ones minus number of zeros, is just 3. And then at position 8, we also have the number of ones minus number of zeros is also 3. What does this mean? It means that the number of ones minus zeros here will be cancelled with also that here. You can think of it as a common window, like this guy as a big window has this window as a common window. It means that from position 4 to position 8 must have the same number of ones and zeros. Try to simulate an example if you are still confused about that. So the idea is as following. We will keep accumulating the current value of total ones minus total zeros. And we will use one array for positive values and another array for the negative value, because if the number of ones is bigger, it will have a positive value. If the number of zeros is bigger, it will be a negative value. If it is the first time to see such a difference, we will mark it in the array. If we met it before, then we have a valid new range that we can make use of it. Let's code it here. I'm creating two lists of positive and the negatives. I'm initializing both of them to -1, which means we didn't see such a difference before. And here I'm having the length of list as the index of me, because in the maximum, if you have, let's say, the array of 10 elements, then the maximum number of ones will be 10. That's why we need an array of 11 elements. In a similar way, the maximum negative value can be negative 11, so we need +1 element here. Now let's go on the list, and the accumulation is the difference between number of ones and zeros so far. So if the item is 0, then we can add -1. If the item number is 1, we can add 0. Now the easy case, if the accumulation is 0, it means that we have actually total number of ones and zeros starting from the first index. So this is definitely the current best length. Now there are two cases. Either the accumulation is positive or the accumulation is negative. If the accumulation is positive, we will do the following. Did we see such an accumulation before? Specifically such a difference between positive and negatives? If -1, then just mark the first index where we met this accumulation before. Why the first? Because the window is growing up, and we need to like the longest window. So the more we keep, we need the earliest window so that we can get the longest window. If we have met this index before, then we can write here that the first index that we have is coming from this position. In the same logic, if we are a negative value, then we are doing the same with the negative array, but observe here I'm using minus accumulation because accumulation is a negative value. Now the first index can be none. If it isn't none, we get the current length, which will be the current index minus the first index appeared, and then we maximize over all the current length. Later with the dictionary, you don't need to learn create positive and negative. You can handle one dictionary with positive and negative values. Back to my question here. I'm saying how to reduce this problem to another problem of longest sublist of zero sum. The reduction idea is a very common idea in computer science. To reduce the problem, you can simply replace every zero with a -1. Now the problem is converted from the number of zeros equal to number of ones to the sublist that has the zero sum. Find the longest sublist that has a zero sum. Again, if you are confused about this solution, this is totally okay. It's a hard solution already.